Welcome students to EPG Pathshala. Today we will learn stabilization, solidification, chemical fixation, encapsulation under the paper Solid and Hazardous Waste Management. So, our objectives are to understand the concept of waste management techniques through stabilization or solidification, fixation and encapsulation, and to understand the management of environmental hazards of improper hazardous waste management due to its improper handling and disposal. And next to understand adoption of scientific and effective waste management techniques and further improvement in improvising of the technology. Starting with the introduction to waste treatment. The process such as stabilization, solidification, fixation and encapsulation are some of the remediation techniques used for the management and disposal of wide range of hazardous waste. In these processes, the waste are immobilized using different chemicals or additives. The contaminants are also encapsulated in a medium to stabilize it. According to Environmental Protection Agency EPA 1989, the process of solidification and stabilization makes the handling of waste friendly, easy and improves the quality of waste. The process helps in reducing the surface area and mass of waste and also restricts the solubility of hazardous substance in the waste. Stabilization is general process through which the waste are changed to less toxic and less mobile form. The process of solidification on the other hand treats the waste material while increases the solidity and structural integrity of the waste. The process of solidification does not render degradation of hazardous waste but removes the transport of waste by restricting its mobility. The transforming of the hazardous waste operation is carried such that the treated hazardous waste will have less effect to contaminate the environment by reducing the leaching potential. The leaching potential can be defined as natural process by which water soluble substance is washed out from the soil or waste. The process of leaching makes the waste less toxic. Now, let us see the mechanisms involved in the treatment of hazardous waste. First, solidification or stabilization. In this technique, waste is solidified using solidifying or adsorption agents and other additives. Second is immobilization or chemical fixation. Here, contaminants are chemically bound within the matrix to restrict the mobility of waste or its leachability. Third is encapsulation. In this technique, waste is captured in a way that reduces and reactive potential and overall volume. These processes are executed in situ as well as ex situ. In situ process, the stabilizing process is directly injected into natural soil. In ex situ process, the soil is excavated and subjected to treatment process, and finally after the remediation it is backfilled. The process of stabilization or solidification is generally appropriate for that kind of soil which is polluted with metals, other inorganic compounds, radionuclides, etc. Volatile organic compounds are usually not preferred for this process because the VOCs have tendency to evaporate into atmosphere during the process of mixing. The process of stabilization or solidification is further characterized into aqueous, polymer and vitrification process. US EPA has recognized the process vitrification as best demonstrated available technology for 57 different types of hazardous waste listed in the Resource Conservation and Recovery Act RCRA. According to US EPA 2001, around 25% of the Superfund remediation locations has been treated using vitrification techniques. Application of stabilization or solidification process. The process of stabilization or solidification is utilized in broad range of medium such as in sediments, soils and sludge. The effectiveness of the stabilization or solidification process according to Superfund policy is determined by carrying a treatability study on similar kind of waste in order to guarantee the effectiveness of the process by 90 to 99%. It is according to EPA 1993. The effectiveness of the process is selective for certain concentrations. For example, at lower to moderate concentration, the solidification of metals such as zinc, lead and copper with the help of cementitious substance is effectual. At the higher concentration of these metals, there is hindrance in the process of immobilization. Hence, it proves to be unsuccessful. This is according to EPA 1993. Moreover, certain combinations and allocations of the pollutants through the soil also prove to influence the success of stabilization or solidification process. Now, description. Stabilization or the solidification treatment process are used to alter chemical properties of the waste in order to facilitate or enable further treatment, to convert waste to non-toxic or non-hazardous for disposal, or to solidify or stabilize the waste for ease or handling or reduced leachability, or to render them non-biodegradable. Now, some of the common methods of chemical treatment include solidification or stabilization, fixation and encapsulation. First, solidification or stabilization, the effectiveness of solidification or stabilization. Effectiveness of stabilization method is tested by its effectiveness to prevent the contamination to the environment. Some of the parameters to verify the effectiveness are performed by examining the physical and chemical factors. Physical tests are performed for the characterization of waste material before and after the stabilization or solidification treatment process. The chemical tests are carried out chiefly for the evaluation of the performance of particular treatment techniques. Some of the tests includes particle size analysis to determine the particle size distribution of a material, to estimate moisture content, paint filter liquid test to determine the presence of free liquid in the representative sample of bulk or non-containerized waste, to estimate bulk density to determine the in-place density. Next, moisture density relation to determine the relation between moisture content and density of the waste. Falling head, permeability or constant head to measure the rate at which water will pass through the stabilized water. Next is unconfined compressive strength to evaluate how cohesive the stabilized material behave under mechanical stress. Then flexural strength to evaluate the stabilized waste ability to withstand load over large area. Then cone index to evaluate stabilized waste stability and bearing capacity. Now, to test permeability testing, falling head permeability or constant head to measure the rate at which water will pass through stabilized waste. Now, durability testing, wet dry durability to determine how stabilized waste behaves or degrades after repeated wet dry cycles. Here is table 2 which shows number of natural sorbents and their capacity to remove specific contaminants from different phases. Here we can see calcium fluoride and neutral waste, basic waste and acidic waste. Neutral waste such as zeolites and acidic waste such as acidic fly ash are used to remove calcium, copper, magnesium, nickel, zinc and fluoride. Now here is table 3 which shows compatibility of some waste categories with different stabilization or solidification techniques. In case of organic solvents and oils, the cement based products may impede setting and may escape as vapor, while pozzolan based product may impede the setting or may escape as vapor, and thermoplastic or micro encapsulations organics to vaporize on heating. So, and in case of surface encapsulation, they are first absorbed on solid matrix. So, surface encapsulation is better for organic solvents, and likewise different waste categories such as solid organics including plastics, resins, tars, acid waste, sulfates, halides have different implications on different products. Now, chemical test. Chemical test generally such as leaching test is performed as an endorsed toxicity characteristic leaching procedure TCLP for the identification of chemical constituents in the stabilized waste. The waste stabilized should meet the best demonstrated available technology BDAT standards before their disposal to the secure landfill. Addition of reagents and additives. Process can be grouped into following: cementitious reagent process and surface adsorption reagent process, which includes organophilic clay and thermoplastics or other synthetic polymers. Cementitious reagents are the most common commercially employed SS process options due in part to low cost and availability. Now, in this figure we can see two images. First image shows before SS treatment and the second image is after SS treatment. So, before SS we can see surface zone footprint on the top, and we can see contaminants just above the water table, and the groundwater below the water table, the soil is low permeable, and below that is bedrock. The figure adjacent to it, which is after SS treatment, we can see the waste in solidified columns, the waste entrapped in a way which makes it impermeable to water table. Now, technology advantages and limitations. Stabilization or solidification methods have resulted in development of reliable information regarding effectiveness and other factors that are typically considered in the process to evaluate and select site remedial actions. In considering use of technology, a sound understanding of site conditions is important, as well as an understanding of the practical outcomes and limitations of the technology. The treatment technology is applicable for a relatively broad range of contaminants and may be feasible when limitations to other technologies are imposed by site or contaminated material conditions. Now, advantages of SS technology. It is effective in treating many inorganic contaminated materials. It is effective in treating some materials contaminated with organic chemicals. There is option for treating mixed contaminants. It often reaches fixed treatment endpoint in relatively short period of time. It can improve structural property of soil, water and sludge, in example strength, to facilitate consideration of land beneficial reuse. Then application for in situ or ex situ treatment has been applied in dry or wet conditions, reducing dewatering and waste management issues. Generally uses simply readily available equipment and material. It is compatible with different types of soil. On-site management of contaminated material conserves space and does not require transportation off-site. It may be more cost effective than evacuation and off-site disposal. Now, challenges of SS technology. Contaminants are not destroyed or removed. Long-term monitoring may be required. Effectiveness for certain contaminants may require more testing, research and developing a reliable design. Soil treated undergo increase in the volume, remarkably potential changes in physical setting, example groundwater flow, molding. When mixed contaminants are present, long-term prediction and behavior is to be studied. Uniform mixing of waste with stabilizing agent are again difficult process. Later, modifications after applying at the site are sometimes difficult to assess and treat. Now, landscape management to refill the unearthed material could pose a challenge. The stabilization or solidification technique cannot be redeveloped in situ. Long-term efficiency cannot be ensured through this process. Now, we will study encapsulation. Encapsulation is a process by which hazardous waste is immobilized in a solid block and sealed inside plastic or steel drum. The containers should be cleaned previously. Containers that had been used previously to contain or transport hazardous waste must be avoided. The waste that needs to be encapsulated must be filled to 75% of container's capacity. The remaining space is filled with a mixture of cement or cement lime mixture, plastic foam or bituminous sand. The proportion of lime, cement and water mixture is around 15:15:5 ratio. Sufficient water is required to maintain the consistency of the mixture. Before the filling process, the drum lid must be cut open and bent back to ease the filling process. Post filling, the lids are brought to original position and sealed by seam or spot welding. The sealed drum should be placed at a base of a landfill and covered with fresh municipal solid waste. For ease of movement, the drum must be placed on pallets which can then be put on pallet transporter. Encapsulation is poorly used for pharmaceutical waste. Now, inertization. Inertization is a type of encapsulation and is again used for pharmaceutical waste. However, inertization process require pre-processing such as removal of packaging material, paper, cardboard and plastics from the pharmaceutical waste. Even pills should be removed from blister packs before the inertization process. The pharmaceutical waste compound are grounded and mixed with lime, cement and water to form a homogeneous paste. The paste is then transported to landfill in liquid form in the containers. From the concrete mixture trucks, the waste is decanted to the landfills containing municipal solid waste. The paste then sets out into solid mass. The required precautions such as protective clothing, masks, gloves must be used by the workers performing inertization. The process is cheap since it does not involve any sophisticated equipment. The main requirements are a grinder or road roller to crush the pharmaceuticals, a concrete mixture and supplies of cement, lime and water. The approximate ratios by weight of materials used in inertization is as follows. Pharmaceutical waste 65%, lime 15%, cement 15%, water 5% or more to form a proper liquid consistency. Now summary. To summarize, we have studied about stabilization and solidification process used for solid and hazardous waste disposal, additives used for stabilizing the waste, technological advances in stabilization and solidification, challenges involved in stabilization and solidification, and concept of encapsulation and inertization. That's it. Thank you so much.